Picture this. Scientists detect a massive star just 25 light-years away, entering its final death spiral. In roughly 100,000 years, it will explode in a supernova so violent that the radiation alone could strip Earth's ozone layer bare. Life as we know it, gone. Now here's the question nobody talks about. What if we could just move? Not evacuate, not send a rocket, not build a bunker, move the entire solar system. The Sunday, Earth, every planet, every moon, every asteroid, just pick it all up and drive it somewhere safer. That sounds like pure sci-fi, but here's the thing, the physics actually works. And the engineering blueprint has already been published in a peer-reviewed journal. So today, we are building humanity's ultimate survival machine, a stellar engine. And by the end of this video, you are going to realize that moving a star might actually be easier than you think. Let's start with something your astronomy teacher probably didn't tell you. The Milky Way is not a peaceful, organized place. It looks calm in photos, this beautiful spiral of stars stretching across the night sky. But zoom in, and what you actually have is closer to a skating rink full of objects, moving at hundreds of kilometers per second, all slightly out of sync with each other, all drifting in different directions with zero traffic laws. Our Sunday is one of those objects. Right now, the Sunday is orbiting the galactic center at roughly 220 kilometers per second, that is 490,000 miles per h-hour, and it completes one full lap around the Milky Way every 230 million years. What scientists call a galactic year. The last time Earth was in this exact position in the galaxy, dinosaurs didn't even exist yet. And here's what makes that terrifying. In those 230 million years of travel, the Sunday's neighborhood constantly changes. Stars that were once dozens of light years away are now light years closer. Stars that used to be far behind us are now ahead. And most of these objects have no idea we're here. The threats are real. A star going supernova within 25-50 light years could bathe Earth in enough gamma radiation to trigger a mass extinction. High-energy cosmic ray events from nearby neutron stars have been linked to multiple extinction events in Earth's fossil record. And rogue stars passing close enough to the outer solar system can gravitationally disturb the Oort cloud, that giant shell of icy bodies surrounding us, and send a hailstorm of comets raining down on the inner planets for millions of years. These aren't hypotheticals, they have happened before, and at some point in Earth's future they will happen again. The difference is, this time we might see it coming thousands, maybe millions of years in advance. The question isn't whether we'll detect the threat, the question is, what do we do about it? Here is the core insight that makes stellar engines possible, and it is genuinely beautiful once it clicks. We don't need to move the solar system, we only need to move the Sunday. Everything else, Earth, Mars, Jupiter, Saturn, the asteroid belt, every moon, every comet, it is all gravitationally chained to the Sunday. Move the Sunday, and the whole system follows like a dog on a leash. The leash is gravity, so the problem of moving an entire solar system, which sounds impossible, collapses into the much cleaner problem of moving a single star. Now, the Sunday has a mass of about 2 st10 to the 30th kilograms. It contains 99.86% of all the mass in the solar system. So you might think moving something that massive is impossible. And in human timescales, yes, absolutely. But stellar engines don't operate in human timescales. They operate in geological ones, astronomical ones. These are machines built to push a star slightly for a very, very long time. And over millions of years, even the tiniest force adds up to something transformative. 2 designs exist that could actually do this, and they're both grounded in real physics. The first design is called the Shkadov Thruster, named after Soviet physicist Leonid Shkadov, who proposed it in 1987. And the concept is almost embarrassingly simple. It is a giant mirror. Not a tiny satellite mirror, we're talking about a parabolic reflective structure so large it would dwarf Earth, positioned above one of the Sunday's poles, hovering there using the Sunday's own radiation pressure to stay aloft. The very photons trying to push it away are exactly what keeps it in place against gravity. Here is how it works. The Sunday radiates photons in all directions uniformly. Those photons carry momentum, not much per photon, but the Sunday emits 3.85 10 of energy. That is an almost incomprehensible amount of light. Now take that giant mirror and hang it over one pole. Instead of that half of the solar output spreading out into space doing nothing, the parabolic mirror redirects it, shooting all those reflected photons in one direction, away from the Sunday like exhaust from a rocket nozzle. This creates a net thrust, not a huge thrust, but a constant one. a sustained asymmetric pressure that, over millions of years, gently nudges the Sunday in the opposite direction. The math works out like this. The Shkadov Thruster could move our solar system about 100 light years over 230 million years. And over a few billion years, you have essentially complete control over the Sunday's galactic orbit. There is one geometric limitation, though, because the thruster has to sit over the poles to avoid cooking or freezing Earth with asymmetric sunlight. The Sunday can only be steered vertically relative to the galactic plane. That limits your directional freedom somewhat. But for a civilization capable of building a Dyson sphere, this is considered the easy version, low complexity, no moving parts. Just physics doing the work. The harder part isn't the engineering concept, it is the sheer scale of construction. You'd need to mine a significant portion of mercury or an equivalent body and process it into ultra-thin reflective foil, probably aluminum alloy, microns thick, shaped into a structure roughly the diameter of a small planet. Simple in theory, civilization defining in practice. Now here's where it gets genuinely mind-blowing. The Shkadov Thruster is slow. If a supernova is 100,000 years away and you need to move 50 light years, the mirror won't cut it. You need something faster. So physicist Matthew Caplan, working at Illinois State University, designed one. He published the paper in the journal Acta Astronautica in 2019, and what he came up with is an engineering masterpiece. The Caplan Thruster is in essence a rocket engine, but instead of burning hydrogen and oxygen, it burns the Sunday itself. Here is the full system, step by step. Step 1, build a Dyson sphere, or at least a partial one. A network of solar collectors surrounding the Sunday, capturing its energy output. This powers everything else in the system. Step 2, use that energy to create stellar wind. The collected sunlight gets refocused back onto specific regions of the Sunday's surface using enormous lens and mirror arrays. This heats small patches to extreme temperatures, hot enough to blast mass off the solar surface in concentrated jets. This process is called stellar lifting, and it is the key to fueling the engine. Step 3, collect the fuel. Electromagnetic scoop fields, essentially giant magnetic funnels, gather the hydrogen and helium blasted off the Sunday and channel them into the thruster station. Step 4, run the fusion reactor. The helium gets fed into thermonuclear fusion reactors. The product of that fusion, radioactive oxygen, gets accelerated and expelled as a superheated jet at nearly 1% the speed of light. That jet is your primary thrust. It pushes the station forward. Step 5, balance the system. Here's the elegant part. If the thruster just pushed itself forward, it would drift away from the Sunday. So a second jet made of the collected hydrogen gets fired backward directly at the Sunday. This transfers the thrust to the solar body itself. The Sunday gets pushed. The thruster station stays in place, held by the balance between its own exhaust and the reaction. The result, a complete system that harvests the Sunday's own mass to push the Sunday through space. The Caplan Thruster consumes millions of tons of solar material per s-econ. That sounds catastrophic, but the Sunday contains 2.10 fine kilograms. At the Caplan Thruster's consumption rate, it would take longer than the current age of the universe to meaningfully reduce the solar mass. And here's the bonus that Caplan himself found extraordinary. Removing mass from the Sunday actually slows its nuclear burning rate. Lower mass means lower core pressure. Lower core pressure means the fusion reactions run slower. This extends the Sunday's lifespan, potentially adding billions of years to the habitable window around our star. The performance numbers are staggering. In as little as 1 million years, a Caplan Thruster could move the solar system by 50 light years. That is more than enough to escape the blast radius of any supernova threat we can currently identify. In 10 million years, the Sunday's entire galactic orbit could be restructured. At full throttle, you could flip the Sunday into a retrograde orbit, meaning it travels backward relative to most of the galaxy, maximizing the rate at which it passes near other star systems. If you wanted to colonize the galaxy star by star, this is how you do it without ever leaving your home system. Here is where the story gets even stranger. If a stellar engine produces measurable effects, slight changes in a star's trajectory, asymmetric infrared signatures from the waste heat of a Dyson sphere, anomalous spectral readings, then astronomers on Earth could detect it, and several teams have tried. In 2024, a research project called Project Hephaestus conducted a systematic survey of millions of stellar objects from the Gaia Space Telescope's data combined with infrared catalogs. The search identified 7 potential candidates, all M-dwarf stars within roughly 1,000 light years of Earth, that showed anomalous infrared excess that could be consistent with partial megastructure enclosure. Wikipedia, nobody is saying these are alien stellar engines. The authors themselves were careful to note that dust or background galaxies could explain the signatures. But the methodology works. New theoretical models published in the monthly notices of the Royal Astronomical Society have strengthened the case that stellar engines and Dyson bubbles could be gravitationally stable under the right engineering conditions, phys.org. Meaning if they're out there, they could persist long enough for us to observe them. Think about what that means. A civilization that built a Shkadov Thruster 500 million years ago would have left a detectable track in the galaxy. A star moving in a subtly unnatural arc, slightly out of step with its neighbors, trailing heat that doesn't match its spectral type. We may already be seeing the fingerprints of engineering at stellar scale, and we don't yet have the resolution to be sure. The Fermi paradox, the question of why, in a galaxy of 400 billion stars and billions of years of cosmic history, we haven't detected evidence of other civilizations, may one day be answered not by a radio signal, not by a spacecraft, but by a star that is simply moving in the wrong direction. Let's bring this home. We are roughly 4.5 billion years into the life of our Sunday. The Sunday has another 5 billion or so years before it begins its red giant expansion, eventually engulfing Mercury, Venus, and quite possibly Earth. That is the hard deadline. The eviction notice from our home system. But here is the thing about a Caplan thruster. By reducing solar mass through fuel extraction, you don't just get thrust, you get time. The Sunday's lifespan could be extended significantly, potentially by billions of years, as a side effect of using it as fuel. So the same machine that lets you move the solar system away from a nearby supernova also gives your descendants more runway on the biological clock of their home star. And if you are willing to think even bigger, a solar system with a Caplan thruster is effectively a spacecraft, the largest spacecraft physically possible. One that carries not just a few astronauts, but an entire biosphere. Billions of people, every species, every ecosystem, flying in formation around a living star. You could orbit backward through the galaxy, passing within colonizing distance of hundreds of star systems over millions of years. You could, in principle, leave the Milky Way entirely, crossing the 2.5 million light-year gulf to Andromeda. Not in a generation ship, but riding your own sun. This is not science fiction anymore. The equations balance. The peer-reviewed papers exist. The physics is understood. What separates us from this future isn't knowledge. It is time. And we live in a civilization that thinks in quarters and election cycles. 4 years, maybe 10, but the universe operates on timescales of millions and billions of years. And if our species is going to survive long enough to matter cosmically, we have to start thinking that way too. The stellar engine is not just an engineering project, it is a statement. It says we are not passengers on this planet. We are not victims of a random universe. We are the kind of species that move stars. Whether that future belongs to our descendants depends entirely on whether we survive long enough to build it. So yeah, maybe we should also figure out the other stuff first. If this video blew your mind, hit subscribe, because we're just getting started on the biggest questions in the universe, and drop in the comments, would you vote to build a stellar engine if you could? I want to see what you think.